Hello my dear friends, students and viewers, this is Sir Palmat and welcome to my video channel. This is the second part of our video lesson which we are talking about the general permutation of objects, which specifically we are discussing about solving word problems which involves general permutation. So let us begin with our learning objectives for today's lesson. So let us start with, we'll be able to illustrate the permutation of objects using the general permutations. Second, you will be able to derive the formula for finding the number of permutations of n objects taken r at the time. And lastly, you will be able to solve problems which involves general permutations. So these are the only 3 learning objectives you need to learn and study some of their illustrative examples which involves general permutation. So my dear friends, students and viewers, so are you ready to study and learn more about general permutations which involves word problems? So let's start. So today, let us recall about general permutations which we have already discussed in the previous video. So this type of permutation is known as the general permutation. The permutation of n objects taken r at the time is denoted by P and R, or permutation of n objects taken r. So the number of permutations of n objects taken r at the time is given by the formula, so which is permutation of n taken r is equal to n factorial all over n minus r factorial, where n is greater than or equal to r. Of course, we have already discussed in the previous video on how to derive general permutations. So we all know that we are using the formula for general permutations, where n is greater than or equal to r. And then we'll be going to expand both of the numerator and denominator based on the given factorial notation. So n factorial, so we have this, and we have this one in the denominator, so which include n minus r. And of course, we added an additional term in order to us to connect on the next factor form, in order to us to cancel of these terms. Of course, we have the formula for permutation, and we all know that we substitute this characteristic formula on the left side, which is back into permutation of n taken r. So we have n times n minus 1 times n minus 2 until reaches to n minus r plus 1. And that r, which is the number of factors depending on the right side of the equation. And of course, we have already differentiated these 2 types of formula using the general permutation. So the general formula, so we use the factorials. And of course, we use the alternative formula, which is the expanded form. Okay? So my dear friends, students and viewers, so today, let us discuss on how you'll be able to solve word problems which involves general permutations. So with that, let us discuss some of their illustrative examples which involves the word problems involving general illustration or permutations. So let us start with our first illustrative example. So how will you find the different arrangements of the set of letters in the word joyful? Joyful. Taken letter A, 2 at the time, letter B, taken 3 at the time, or letter C, taken 4 at that time. So to solve this set of problems which involves general permutation, so here is the solution to the given problem. So for letter A, we are take 2 at the time among these 6 letters in the word joyful. So we all know that the value of n is equal to 6 since there are 6 letters in all in the word joyful. And we need to take 2 at a time, so we let r is equal to 2. Thus, the given formula we are using for the general permutation. So the permutation of n taken 2. So we need to take 2 numbers, so we have to put 2 factors. So starting from 6, so it begins at 6 times, decreased by 1 is 5. So 6 times 5, so we get 30 different arrangements of 2 letters among of these 6 letters in the word joyful. So that is the final answer for letter A. So how about taken 3 at the time? Okay, so to solve this problem, so let us identify first the value of n and r in a given problem. So we let n is equal to 6, so still the same, so there are all 6 letters in the word joyful. And the value of r, so we need to take 3 at a time, so let r is equal to 3. So that's the following. So we express as a permutation, so permutation of 6 taken 3, so which is equal to, starting from the largest value, which is 6, times 5 times 4, so decrease by 1 every factor. So 6 times 5 equals to 30, times 4 is equal to 120. So there are 120 different arrangements of 3 letters in the word joyful. So that is the final answer. So how about for letter C? So taken 4 at a time. So this is in the same manner, so that we let the value of n is still 6, so there are 6 letters in all, and we need to take 4 at a time, so we let r is equal to 4. So that's which express into permutation form. So permutation of 6 taken 4 at a time is equal to expanded form, so 6 times 5 times 4 times 3. So there are 4 letters. So we have 6 times 5, 30 times 4, 120 times 3, 360. And these are only 360 different arrangements to arrange the 4 letters at a time. And that is the final answer. So my dear friends, students and viewers, so let's move on to our second illustrative example. How many possible permutations are there if 4 cards taken from a standard deck of 52 cards? Assuming that there is no same card. So when you draw a 4 cards, any of this sequence, so here is the solution to the given problem. So that we let the value of n is equal to 52 because there are 52 cards in all in a deck. Okay, so number of cards in the deck, and the value of r is equal to 4, so we need to take 4 cards among the 52 cards in a deck. So we express into permutation form, so that we have permutation of n taken r is equal to permutation of 52 taken 4. And then there are 4 numbers that we put below. So starting from 52, so 52 is the first number, decreased by 1, so times 51, times 50 on the third number, and of course times 49 on the last number. So we get the product of these 4 numbers, so by the use of calculator, so we get 6,497,400 possible permutations when you take 4 cards at the time among the 52 cards in a deck. So that is the final answer. So my dear friends, students and learners, so let's move on to our next illustrative example. 7 different books of fiction and 5 different books of fairy tales are to be arranged on a shelf. The question is, how many ways it can be arranged if letter A, books of the fairy tales must be together, and letter B, books of the fiction must be together. So to solve this set of problems given, here is the solution to the given problem. So we all know that 7 different books of fiction and 5 different books of the fairy tales are arranged, must be on a bookshelf. So let us start with our question for letter A. So we are looking for the number of possible arrangements that the books of fairy tales must be together. So all in all. So we let n is equal to 12. So 7 fictions and 5 fairy tales. So among the 12 books, so we need to take that 5. So why is it the value of n equals 12? Because we add all 7 plus 5. So 7 fiction books and 5 fairy tales, so we get value of n is equal to 12. And r, so we need to take 5 fairy tale books. So by the use of permutation formula or the shortest formula, so we all know that there are 5 numbers to be put. So 12, starting from 12 times 11 times 10 times 9 times 8. So there are 5 numbers. So 12, 11, 10, 9, and 8. So we get the product of these 5 numbers. So we get a product which is 95,040. And that is the final answer. So these are the number of arrangements if the books of fairy tales must be together. So out of 12 books in all, so we choose 5 fairy tales. Okay? So in the same problem given, so how about letter B? The books of fictions must be together. So in the same manner, we all know that there are only 12 books in all, so 7 plus 5. And of course, we need to take 7 fiction books be taken among of these 12 books. So that is R is equal to 7. And then we'll be able to express into permutation forms of permutation of 12 taken 7. So which is equal to the product of 7 numbers. So 12 times 11 times 10 times 9 times 8 times 7 times 6. And we get the product by the use of calculator if necessary. So the product is 3,991,680. And that is the final answer to the given problem. Okay? So my dear friends, students and learners or viewers as well. So now you know how you'll be able to solve general permutations using the word problems. So my dear students, viewers, and of course our friends. So that's the end of our video for today. So thank you very much for watching. So please like, share, subscribe, and hit the notification bell here at my YouTube channel, Sir Palmat TV. So thank you very much and see you on next video. God bless us all.